Unit 1, Lesson 5, Measuring Length, Part 2. Your learning goals. Determine if the line segments are congruent. Identify and use the segment addition postulate and the segment congruence postulate. Identify a point that is between two other points. First, let's talk about congruent line segments. They are line segments that have the same length. Okay, so when we're in geometry, line segments being equal, when we talk about them being equal, we know their value. Okay, so we can say that AB equals 4. Okay, so that is something being equal. If we are just talking about general line segments, AB and CD, we both know that they are 4. So when we talk about a line segment, and we're going to use line segments in our sentence, we're going to use the word congruent. Okay, this symbol right here, we have a little wavy line and then the equal sign underneath it. That is the sign for congruence. That is when we are talking about line segments, lines, angles. Okay, when we're naming those things, we use the congruent sign, not an equal sign. Okay, they mean the same thing. Congruent and equal mean the same thing. It's just where we use them. Okay, some notation that we're going to be using in geometry. Okay, if you look right here, I've got that AB is 4 and CD is 4. Okay, and then right here I use this little tick mark. Okay, and that's what we call it. We call it a tick mark. Okay, if they have the same tick mark, that means that they are congruent to one another, or they equal the same number. Okay, so I'm using a different tick. I'm using 2 tick marks. So I've placed 2 marks right here. Okay, that's to show that EF is congruent to FG. Okay, and I use the congruent sign because I'm not using a number in here. I'm using actual line segments. Okay, so we use the tick marks to show congruence. Okay, so let's look at an example of this. It says in the figure below, what line segment is congruent to JK? So we're going to look at JK. Okay, there's JK. JK has 1 tick mark. So then I go and I look and I find the other tick mark and say, okay, well then that one has to be congruent because it has the same tick mark. So it says which one is congruent to JK, and your answer would be line segment NK. Or KN, either way you say it, it's still the same line. Okay, now let's look at postulate 1-4. Okay, any of these postulates that we are going to use these in proofs, so you need to make sure that maybe you have like a composition notebook or a piece of paper or a Word document file that you're keeping these postulates in to just kind of have a running book of what you need. Okay, this is the segment addition postulate. It says if point B, right here, is between points A and C, there's A, there's C, on a line, okay, so they're all collinear, then AB plus BC equals AC. So let's look at that. So then AB, so this would be AB, this length right here. BC is right here. If we add those two together, those two distances, I'm going to draw it down here, you will get the length of AC. Makes sense, right? Okay, whatever the distance is from A to B, and then the distance from B to C, if B's in the middle, add it together and you should get the full length. That's all it's saying. Let's look at postulate 1-5. It's the segment congruence postulate. And this might just kind of be, you're like, oh, well, yeah, that makes sense. But we still have to claim it as a postulate, that we're going to say that it's absolutely true. Remember, that's what a postulate is. Postulate doesn't have to be proven. A postulate we just take to be truth. It says if two segments have the same length as measured by a fair ruler, then the segments are congruent. Okay, same length, congruent. Also, if two segments are congruent, then they have the same length. Okay, so right here we have that AB is 4 units. Alright, we have that CD is is 4 units. Since they both are 4 units, we can write the statement AB is congruent to CD. Okay, so now let's run through some examples together. It says, what is the length of AB? Well, we have a thing that we just learned. We have these tick marks. We have this tick mark and this tick mark. Okay, so if from A to M is 5, then from M to B also has to be 5. Well, we want to know the length of AB, so we want to know the length all the way here. Well, what do we use? We just use our segment addition postulate, and we add those two things together. So 5, hold on, sorry, had a glitch. 5 plus 5 equals 10. That is the length of AB. If point B is between points A and C, and AB is 5 and BC is 4, then what is AC? Anytime you're given a problem like this, my best advice to you is to draw a picture. So I'm going to take my pen, draw a line. Okay, these are all collinear. Point B is between A and C, so I'm going to make 3 points. There's 1, there's 2, there's 3. Okay, the distance might be a little weird, but that's fine. And then I'm just going to label them. So I'm going to say, okay, B has to be between A and C. Then AB is 5. Okay, so I'm going to label that. And BC is 4, so I'm going to label that. Then what is the distance between AC? So I want all of this together. All I do is I add those because I use that postulate, and I say my answer is 9. This is how you work through these problems. Here's another one. If point F is between points E and G, okay, so let's stop right there and just go ahead and draw the picture. Okay, so I'm going to draw my line. So I've got E, F is in the middle, and G. EF is 12, okay, so I'm going to go ahead and label that. EF is 12. And then EG is 28, so let's pay attention here. I know that EG, so E to G, is 28. I'm wanting to know what is FG. So now it's a little bit different. I still use the same postulate, I just have to work it backwards. So I'm going to say, okay, 12 plus FG is going to take you back to algebra equals 28, because this is the postulate. I take these two line segments, add them together, and I get the whole distance. Okay, well then all we have to do, isolate what we need to know, and then solve the equation. So to get rid of positive 12, I'm going to subtract 12 from both sides. Okay, so FG equals 28 minus 12 is 16. And there's your answer. Okay, we just set it up like an algebraic equation. Still going to use that algebra here in geometry. And there you go. Alright. Then here's one. It says if xy, so we're not really going to work with numbers here. It says if xy plus zy equals xz, what do you know about point y? Assume points x, y, and z are collinear. Okay, so this is just, we're just answering this question. Okay, we have x, y, so let's mark that on there, x to y. And then we also have points z to y. Okay, well z can't be in anywhere in here. Let's put z here. And then you know that xz, if I add those two together, I get this full xz. Okay, so what does that tell you about point y? It is located in the middle. That's what you know about point y. Okay, if you have, so you have these two line segments, okay, and then y is in both of them, but then at the end, y is not in there. What does that tell you about y? It's in the middle. Okay, it's the midpoint, or the in-between point of x and z. Okay, so in conclusion, line segments that have the same measure in the same units. Okay, so make sure we're talking feet to feet, inches to inches, miles to miles. They are congruent. If point B is between points A and C on a number line, then AB, let's go ahead and do this, then AB plus BC equals AC. All right, have a good day.